Hey friends, welcome to the YouTube channel all about electronics. So in this question, we have been given the circuit and as you can see, it consists of two comparators and few logic gates. So here, this input signal is applied to these two comparators and based on the input signal, these two comparators will be high for certain duration. So as you can see, the output of the comparator is given to this logic circuit and based on this logic circuit, this output will be high for certain duration. So here we have been asked to find for a what fraction of time this output is in the logic high state. So let's say the output of the first comparator is equal to x and similarly the output of the second comparator is equal to y. So here these two outputs will be equal to x bar and y bar. That means the output of this first AND gate will be equal to x bar dot y bar. And similarly, the output of the second AND gate will be equal to x dot y. That means if we see the output of this OR gate, then that will be equal to this x bar dot y bar plus x dot y. And that is equal to this x nor y. That means we can replace this entire logic circuit with the XNOR gate. So here, to find the output waveform, first of all let us find the waveform of this x and y points. And first, let us find the waveform of the first comparator. So as you can see, this sinusoidal signal is applied to both comparators. So for a sinusoidal signal, this one duration is from 0 to 2 pi. And the amplitude of the sinusoidal signal is equal to 6 volt. So in the first comparator, this input is applied at the inverting terminal and this non-inverting terminal is at the 3 volt. So here, until this input signal reaches the 3 volt, the output of the comparator will remain high. So this voltage corresponds to 3 volt and up to this time, the output of the comparator will remain high. Now after this point, this input signal at the inverting terminal will be more than 3 volt. And therefore, now the output of the comparator will become low. That means during this duration, the output of the comparator will remain low. Now after this point, this input signal once again becomes less than 3 volt. That means once again, now the voltage at the non-inverting terminal is more than the inverting terminal. And therefore, from this point onward, now the output of the comparator will become high. So this will be the output waveform at the first comparator. So as you know, for the sine wave, this sine pi by 6 or the sine 30 is equal to 1 by 2. That means at this point, this input signal amplitude will be half of the maximum amplitude. That means this point corresponds to pi by 6. Similarly, at this 5 pi by 6, the amplitude of the sine wave is equal to 1 by 2. That means this point corresponds to 5 pi by 6. That means during the pi by 6 to 5 pi by 6, the output of the first comparator will become low. So similarly, now let us find the output of the second comparator. So in the second comparator also, the input signal is applied at the inverting terminal while the non-inverting terminal is at the ground potential. That means for the second comparator, whenever this input signal is more than 0 volt, then the output of the comparator will remain low. And whenever the input goes below the 0 volt, then the output of the comparator will become high. That means for the second comparator, up to this point, the output of the comparator will remain low. And when the input signal goes negative, then the output of the comparator will become high. So this will be the waveform of the second comparator. And these two waveforms will be applied to the XNOR logic. So now, to find the output of the XNOR gate, first of all let us represent these X and Y waveforms side by side. So as you know, the output of the XNOR gate can be given as x dot y plus x bar dot y bar. That means whenever both inputs are equal, then the output of the XNOR gate is equal to high. So in this case, during this duration, the output of the both comparator is equal to low. And likewise, during this duration, the output of the both comparator is equal to high. That means if you see the overall output, then it will look like this. So during these two durations, the output of the XNOR gate is equal to high. So as we have seen earlier, this time duration is from pi by 6 to 5 pi by 6, and this duration is actually the negative half cycle, that is from pi to 2 pi. So we can say that the output of the logic circuit is equal to high from 5 pi by 6 to pi by 6 time, or during the 4 pi by 6 time, and likewise it is high from 2 pi to pi duration, that is equal to pi. That means the total time duration for which this output remains high is equal to pi plus this 4 pi by 6, or that is equal to 10 pi by 6. So if we compare this time with the total time duration, then that is equal to this 10 pi by 6 divided by 2 pi. So this 2 pi is the overall time duration, and out of this 2 pi, for this 10 pi by 6 time duration, the output remains high, or we can say that that is equal to 5 by 6. That means this is the fraction of the total time duration for which this output of the given circuit remains logic high. So from this we can say that for the given question, this D is the correct answer.